All right. Once again, starting a little late, but that's okay. We can get right into this. Where were we yesterday? We had been working on... let me switch over. There we go. We had been working on trying to figure out how to instantiate a class and getting this little 3-line program to work. So we had gotten pretty far, I think, and right after I was done streaming yesterday, I was kind of stuck figuring out how to get the class. What is it called? Yeah, trying to figure out how to get the this instantiation working. And I think the only thing I was missing from it was the fact that we can't pass in class like this, but class is already RC, so we can just clone it right here, I think. Because right now I think the error is that you can't move the class, right? And we're not trying to move the class. We're just trying to pass in an RC of the class. So if I do an RC class clone like that, and then look at instantiate, let's see what instantiate looks like. It does take an RC, so that should work, hopefully. And then when we create locks instance new, we clone the class into the locks instance. Okay, so was that the only thing I was missing? No, expected reference. Yeah, so maybe this will work. Maybe I was just one step away from getting it to work yesterday, and I just didn't realize it. So we're not going to do this call business. We're just going to do the instantiation. Although, I guess we just haven't gotten to the point where we're going to pass arguments into the initializer. Right now, it doesn't take any arguments. Maybe that's coming soon. All I did was copy paste, and I don't like the fact that we checked this twice. Yeah. Oh, and the other thing I wanted to clean up. Okay, we'll do that. If we get this working, I want to clean this up so that the locks callable doesn't have a toString function. It was just that we implement toString for each thing that we want. Oops. Yeah. Okay. So cargo run. So class bagel. All right. Var bagel. Bagel. Cross our fingers. This works. It didn't crash. Print bagel. An instance of bagel. Okay. Program doesn't do much, but it's starting to do something. All right, so this is section 2.3. And I just want to amend that and change the message. How do I do that? Let's look it up. Git amend last commit. I looked it up before, obviously. I just don't do it often enough to remember how to do it. Git commit amend. Oh, and then I probably have to set the editor, right? Because it'll pop me into it. No, if I do it -m, section 12.4, class instantiation. I think I can just do this. Yeah, okay, so now the broken code's gone. Good, so let's take a look at the full, just trying to grab that first line there. Git log, or git show. Right, so we added, we changed the class so that it now has it's an RC. Instead of calling the class, we instantiated. I should have gotten rid of that line there. How do you? It lets you edit the previous. How do you no edit it? There's a no edit. There it is. Okay, so I'm going to remove that line and do a no edit. And then we added an instantiate function. So we're not calling the class anymore because that was too awkward in Rust to do it. So we couldn't pass in the RC for the class. So yeah, let's edit the class. No, the interpreter, and remove class call. Oh, something in the interpreter? What was that in? It is an interpreter. visit call expert. There we go. It's right near the end. Oh, I did delete that. What am I misreading here? This just looks green as though it's in there. I'm confused. Git log. Oh, git diff. That's what I forgot. Okay, git add source and then amend. Okay, git show head. There we go. Okay, that's what I wanted to see. Wow, I am poor at git. Good. Okay, so that's section 12.4 done. Let's do 12. Oh, that was 12.3. All right, we have to amend again. Can I do this without having anything staged? Get logged. Yeah, there it is. 12.3 class instantiation. Okay, so you can just edit the commit message without having to have any changes in the files. Okay. We're clean. I want to push this up because this is what I was supposed to do yesterday after getting it working, and now we're going to do properties on instances. All right. We have instances, so we should make them useful. We're at a fork in the road. We could add behavior first, methods, or we could start with state, properties. We're going to take the latter because, as we'll see, the two get entangled in an interesting way, and it'll be easier to make sense of them if we get properties working first. Locks follows JavaScript and Python and how it handles state. Every instance is an open collection of named values. Methods on the instances class can access and modify properties, but so can outside code. Properties are accessed using a dot syntax, some object dot some property. Allowing code outside of the class to directly modify an object's fields goes against the object-oriented credo that a class encapsulates state. Some languages take a more principled stance, and small top fields are accessed using simple identifiers, essentially variables that are only in scope inside a class's methods. Oh, that's interesting. Ruby uses add followed by a name to access a field in an object. That syntax is only meaningful inside a method and always accesses state on the current object. Locks, for better or for worse, isn't quite so pious about its OOP faith. All right, expression followed by dot and an identifier reads the property with that name from the object the expression evaluates to. That dot has the same precedence as the parentheses in a function call expression, so we slot it into the grammar by replacing the existing call rule with this. After primary expression, we allow a series of any mixture of parenthesized calls and dotted property accesses. Property access is a mouthful, so from here on, we'll just call these get expressions. All right, so let's add get expressions. And we're going to start off by modifying our AST get. So it takes and we wrap this in RC, and it's called object and token name. Okay, so that's get. Following the grammar, the new parsing code goes in our existing call method. All right, so we'll pull up the interpreter. Oh, no, parser. Call, here's call. So while true, that's the loop, match left paren, else if self is match, token type, dot. That name is self-consume. Identifier, and then it's going to be expect property name after dot, question mark, semicolon, and then expr is equal to self. No, is so what we're doing is self-finish call here, and then we wrap it in OK here. So expr is equal to expr get rc new get expr, and it has two things in it. It has the expr, which is it needs to be wrapped in an RC, right? It's called object rc new expr, and then the token, which is the name. right? And then it gets wrapped in OK, and we're done. Okay. The outer while loop there corresponds to the star in the grammar rule, right? That's this star over here. And we zip along the tokens, building up a chain of calls and gets as we find parentheses and dots like so. Egg.scramble of 3 dot with cheddar. So egg.scramble, that's the get expression. Then it becomes a call expression with 3 as the argument. Then dot with is the get expression. And the call expression is cheddar. All right, that makes sense. So is this check at least? Oh, right. We haven't done the resolver or interpreter for this yet. But those are the only 2 errors, so that means the other thing that I just added checks. So inside resolver, which I was just there, let's add function. Is it get expr? And it's going to take self and rc expr and expr of get expr, and it's going to return the result. Oops. There we go. And it's going to have self resolve. Thus, object is an expr, right? So we have to use resolve expr. So I'm just following this here. It says init. Oh, I'm cloning it here. Why am I cloning it? I don't remember why. Let's see if this works. And then just return OK. Why didn't I put blank lines in these? There's a couple more. Let's add those. Okay, so does that check? No, I still have 2 errors. Expected struct RC. Okay, so we just pass it that way? Yeah, okay. So then that's the resolver. Okay, not much to that. Since properties are looked up dynamically, they don't get resolved. Oh, okay. During resolution, we recurse only into the expression to the left of the dot. The actual property access happens in the interpreter. You can literally see that property dispatch in locks is dynamic since we don't process the property name during static resolution pass. That makes sense. If you're not doing it statically, it's got to be done dynamically. All right, so in interpreter now, is it get expr? I guess we can just yank this and put it here and then just change call expr to get expr, right? All right, we're going to say let object equals self evaluate expr dot object dot clone. I'm just following this thing here because we must have figured it out before. And then we can say if object is instance of locks instance. So this is where we use a match. Oh no, we can just say if let sum. No, not sum. If let object instance inst is equal to, right, object. Then we're going to return an OK of inst.get expr.name. Else error locks result runtime error expr.name. Oh, that has to be like that, and then only instances have properties. Is that it? First, we evaluate the expression whose property is being accessed. In locks, only instances of class have properties. Classes have properties. If the object is some other type, like a number, invoking a getter on it is a runtime error. If the object is a locks instance, then we ask it to look up the property. It must be timed to give locks instance some actual state. And map will do fine. Okay. So we don't have get yet on instance. Method not found on locks instance. Okay. So, oh, that's right. That's this. Okay, so we just need to add a get. So we're going to add a map to locks, which is going to have the fields. Oh, do we need this to be pub? I don't think we need that to be pub. Let's find out. Fields is going to be a hash map of string to object. Okay. But the reason I'm hesitating is because I'm trying to think we're going to need to modify these. This is getters, which is fine. We don't need to do anything. But for setters, we're going to need to be able to update the hash map. So I might have to make this a ref cell. So let's just do that. Well, let's wait until we need it, and then we'll make the change at that point. Hash map of object. Oh, is that? Oh, string to object. I was just for a second worried that I had to make object hashable, and I may already be. No, it isn't. Okay. Oh, you know what I was supposed to do before I even started all this getter stuff? Okay. I was going to fix up the whole two-string thing. Okay. Oops. Let's finish this out. I see set expressions down here, so let's get getters working. Although you can't test them because you don't have setters yet. But we can at least write this, right? Pub fun get name token return a result of object or locks result. So that means we need use crate. That means we're going to say if field contains key, returns fields.get. So we might have to clone it out, right? I'm just trying to think if there's an easy way to do, because we could do this, or we could look up the entry, right? I want to try to get that bit into my brain. Rust hash map entry. Because you can pull the entry out and then just return the value. Using if let. Or these are for gets. And you have and modify, insert entry, or default. Right, I want to see. Yeah, this is what I was looking for. If let entry occupied O is equal to self fields entry of name as string, then return OK of O dot get. Yeah, O dot get dot clone. Else. That way you only do a single lookup, right? This is doing a double lookup here, right? You say contains key does a lookup to find the key, and then a get does a lookup to find the key. Whereas if we have the object, if we look it up directly and we see it's occupied, then we're good. Otherwise, we're going to try error locks results runtime error. Name undefined property. Oh, I gotta format this. Format bang undefined property. Name and string. Right? Oh, I missed something. What did I miss? That's correct. This is okay. Oh, I missed this one here. Okay. There we go. How's that look? That looks terrible. Oh, right. I have to import it. That guy. Use let's paste that, and then I guess we can just add the hash map like that and stop doing that. I really wish that would stop. Okay. Once I get a keyboard with an actual physical function key thing, then I'll stop doing that. Great. Okay. Star. What else is missing? This. Oh, it doesn't have self. Duh. And we're missing fields, which is going to just be default. Oh, I guess I can't do that. Okay. Fields, hash map. No. Fine. Like that. Oh, that's why it was pub. Okay, so that's why I want to avoid that. Let's make it its own toString. Let's impl toString for this guy. Right here. Impl toString for locks instance. Oh, what was it? Standard something. I think I have it here, yeah. Just say format bang. Oh, I was going to put instance of, but we already have instance of here. So I can just do this. And then just say instance of, and then we can refer to the class, right? Like that. Nope, doesn't work. Oh, self. Method can't be called due to unsatisfied trait bound. Really? Does Nox class not? It's right there. All right, well, maybe it's time to clean this up now. All right, so let's get rid of this comment. Let's get rid of this guy. Let's change our callable. So there's no toString inside locks callable. And actually, why is callable locks callable? It shouldn't be. It's just a wrapper for it. We shouldn't need that. That's confusing. All right, and then we have to clean up all the errors we have as a result. Oh, so callable needs a toString. Or does it? We can just say this is a callable because this is just a wrapper. Oh, because this implements callable but not. Oh, that's why. Can we derive debug? Was there a problem with doing that? I just want to see if we can clean those up. Okay, that's that error. I don't know what that means. I don't know what the error is here. Oh, yeah, locks callable doesn't implement debug. So we do need to add, we can't just derive debug. So I'm just gonna put callable in here. I don't know what this is gonna do. I wonder if can you combine traits? Can you say it's RC of this plus toString? I don't know if you can do that. No, only auto traits can be used as additional traits in the trait object. Okay, so you can't do that. And now it's complaining about that, and now it's complaining about this. Expected union object O. Found result. Wait, really? Object is we put a question mark after evaluate, so this should be a result. What type is that? This expression has type object. Right. So if we do this now, what type is this? That's a locks instance. Oh, it's what inst is returning in the get is returning a result. Oh, right. So we need to question mark that. Got it. Okay. My brain was a little confused. Oh. In order to do this, I need this to be mutable in order to do it this way. Huh. Even though I'm just getting it as an immutable reference. How do you force that? I mean, I could always just do the ref cell now, like I was saying before. Right? Just do this, and then we can borrow mute, even though we're not changing it. Oh, do I have to do a clone on that? Yeah, that's why I have to clone them. And deref them, I guess. Alright, so we have 3 warnings. Field is never read token in locks function. In locks function. And then resolve expr. Oh, I need to put a question mark after that. Okay. That's easy to fix. Oh, I guess I should implement toString for this guy, because that'll print out the token. Let's take a look at object. When we write out the function, oh, I just put function. I should actually say, you know, this. F.toString. Why not? And it doesn't implement toString, so let's implement toString. And bowl. Oh, what was the syntax for that? I've already forgotten. Class. There it is. So self name. Format bang. Function. Like that. Self name. And string. I think I have. Locks function. method not found in callable. Oh, right, because the locks function is a callable, not a locks function. That's a shame. I do have display for callable and debug for callable. I guess I could I guess we don't need this then. Oh, but callable doesn't know. That's a shame. That's a shame. There's got to be a better way to do this then. Because locks function implements locks callable. It also implements toString, but we don't know it here. That it implements toString. So this whole trait business with the locks callable is kind of leading me down the wrong path. All right. And I can't use F there anyway. I just realized that. All right. Okay. And we've implemented toString for locks function, but I don't think it gets used anywhere. No. All right. So do we have getters? We have getters and a complete mishmash of the whole toString business. I meant to do a cargo run. If I say var a equals foo, print a dot thing, only instances have properties. So now I should be able to say class bagel var b equals bagel, print b dot thing, undefined property. Okay, so we're getting there. We just don't have setters. So we have getters. It actually got something. That's good news. Let's make sure Clippy's happy. I haven't checked in with Clippy in a while. What is this saying here? Locks class. Writing string instead of stir involves a new object where a slice will do. So we can just say stir and then help change name clone to name toString. Okay. But if I do that, yeah, okay. Are we all good? We're good. Git commit -m section 12.4.1 get expressions and some toString cleanup. Okay, we're good. All right, let's work on. Let's make sure we got this right. So this is to get looking up a property on an instance. Doing a hash table lookup for every field access is fast enough for many language implementations, but not ideal. High-performance VMs for languages like JavaScript use sophisticated optimizations like hidden classes to avoid that overhead. Paradoxically, many of the optimizations invented to make dynamic languages fast rest on the observation that even in those languages, most code is fairly static in terms of the types of objects it works with and their fields. An interesting edge case we need to handle is what happens if the instance doesn't have the property with the given name. We could silently return some dummy value like nil, but my experiences with languages like JavaScript is that this behavior masks bugs more often than it does anything useful. Instead, we'll make it a runtime error. So we did that, and we saw that actually working here. So the first thing we do is see if the instance actually has a field with a given name. Only then do we return it, otherwise we raise an error. Note how I switched from talking about properties to fields. There is a subtle difference between the two. Fields are named bits of state stored directly in an instance. Properties are the named things that a get expression may return. Every field is a property, but as we'll see, not every property is a field. Ooh, foreshadowing. Spooky. In theory, we can now read properties on objects, but since there's no way to actually stuff any state into an instance, there's no fields to access. Before we can test out reading, we must support writing. All right, so let's dig into set expressions. Setters use the same syntax as getters, except they appear on the left side of an assignment. In Grammarland, we extend the rule for assignment to allow dotted identifiers on the left-hand side. Unlike getters, setters don't chain. They don't. However, the reference to call allows any high precedence expression before the last dot, including any number of getters, as in breakfast.omelet.filling.meat equals ham. That certainly looks like it's chaining. Note here that only the last part, the dot meat, oh, it's the setter. The omelet and filling parts are both get expressions. Got it. Get it? Got it? Good. Okay, so this is a get omelet, get filling, set meat equals ham. Got it. Just as we have two separate AST nodes for variable access and variable assignment, we'll need a second setter node to complement our getter node. So under logical, we put set. So that should be similar to assign, where we have a name and a value. This has a name and a value, but also the object that that name belongs to. So that's the difference between the assign and the set. In case you don't remember, the way we handle assignment in the parser is a little funny. We can't easily tell that a series of tokens is the left-hand side of an assignment until we reach the equal sign. Now that our assignment grammar rule has call on the left side, we can expand to arbitrarily large expressions. That final equal may be many tokens away from the point where we need to know we're parsing an assignment. Instead, the trick we do is parse the left-hand side as a normal expression. Then when we stumble onto an equal sign after it, we take the expression we already parsed and transform it into the correct syntax tree node for the assignment. We add another clause to that transformation to handle turning an expr get expression on the left into a corresponding expr set. That seems like all this thinking, and it turns into 2 lines of code. Okay. Oops, what did I do? Didn't need to put that there. Okay, so in our parser, assignment, this returns a new, this says if it's a variable expression, then return that. So I think that's what we're doing here. Else, if expr get expr equals expr. Right? If it is a get expression, then we're going to transform it into a set expression. Oh, we don't even need this line of code in Rust because we just did it here. So we're going to say return, okay, expr, set, rc new, set expr, and it's going to have the object, which is going to be get object. Doop. I don't know what the object type is. Is it expr has a name? What is get object that way? Because this returned an expr. Oh right, it's a get expr. Okay, so let's take a look at the grammar again, real quick here. So the get does have an object and it's an RC expr. So we can just clone it, right? And then we need a name, which is going to be the name of the getter, expr name, dupe, right? And then the value, which is RC new value. Can I just do RC clone here? Like that. And that's that. That's set, that's RC, that's a set, and that's the OK, semicolon. What does this think? Right, we don't have the resolver and we don't have the interpreter, but we do have 5 errors. This didn't work. Expected struct RC found expr. Oh, I guess we can just use the get they have here. Okay. I guess it's a different type. Whereas this one is the same type. Okay, let's try again. Oh, if let. Oh, yeah, okay. Well, I guess the expert would have worked. Single equal. We have this, we have this. Oh, okay, we got it good. We got it working, sorry. That's parsing our syntax. So you take the get expression, you realize that there's an assignment. So it's really a set expression. So you pull it apart and make it a set expression and throw away the get expression. That's parsing our syntax. We push that node through onto the resolver. So here's our resolver. Visit set expression. Guess once again I can just copy paste. Change the set to a, sorry, change the get to a set. And we're going to say self resolve expert value. I guess it's just expert. Can I do that? Do I have to clone it? Self resolve expert object. We'll find out. I might have to clone those and then just okay. Okay, let's find out. No, that's it. There's only one error. So those worked. Or it didn't, they didn't complain yet. Right? Because we don't have the interpreter part. Let's stub out the interpreter part real quick. And just make sure that the resolver, yeah, the resolver did work. Okay. We don't want to move it. We'll just do the clone. Okay. Yeah, so now with our interpreter, let's do that. Again, like expert get, the property itself is dynamically evaluated, so there's nothing to resolve here. All we need to do is recurse into the two sub-expressions of the expert set, which is the object whose property is being set and the value it's being set to. This seems to indicate it doesn't matter what order they go in. I guess not. That leads us to the interpreter. So let's see what we're going to do here. We start off by saying let object is equal to self-evaluate expert object clone. That if let object instance inst is equal to object. And we say let value is equal to self-evaluate. I guess like this expert value. No, maybe not this value clone. Looking here. I guess maybe we don't have to clone that. I don't know what you have to clone and what you don't. And then we have the set expression. We're going to say inst.set, which we don't have yet. We haven't written that part. Expert name value. And then just okay. Oh, we're going to return the value too. So we have to clone the value into the instance and then return the value. Else, error, locks error, locks results, runtime error, expert name, only instances have fields. Okay, so does that check? method set not found, right? Yeah, I don't need to do that. And then line 120, there's an associated function with some. Okay. I think what was throwing me just for a second there is that it's pointing here when I did the check instead of pointing up here saying instance set. Okay. Okay, good enough. All right, so let's go to locked instance and write our setter. I mean, there's one line, right? But let's see how this goes. Pub fun set self name. Oh, yeah, name token, and then value object, and it doesn't return anything because why would it? So then we say self fields borrow mute insert name as string and value. Is that it? That's all we have to do? Of course not. That. This. Oh, we do need to clone that. Okay. All right. Lots of cloning going around. At least we're just cloning the reference counted variable. We're not cloning the entire thing, right? So the best thing to do would be to rewrite this whole thing without all that noise. But okay, so now we should be able to create a class bagel and have a set on it. First, I can say var a equals foo, a dot thing equals 3. Only instances have fields, so it clearly parse something the right way somehow. Class bagel var b equals bagel, and then we say b dot thing equals 3. Didn't complain. What does this look like? We have a bagel, which is a class. We have an instance of a bagel and has no fields on it. That's not good. So the set didn't work. Uh-oh, that's a problem. Print b dot thing. Yeah. So it accepted this as a thing. Or I shouldn't have used the word thing. It accepted this as a statement, but didn't actually update. Let's make sure at least are we calling this. I think we are, but it's just maybe we're calling it on a clone instead of on the actual instance, which is bad. So we have to figure this out. Setting to this, and we can say name. Do I have debug on those guys? I do. Okay, so let's try it again. Actually, let's make a little lock test here. Setter locks. Class bagel. Var b equals bagel. Print b. B dot whatever equals 12. Print b dot whatever. Cargo run setter. Okay, so it set whatever to num 12, but it doesn't have it actually on the get side of things. And that must be because of all the stupid cloning I'm doing. Visit set expression. Okay, so let's take a look at our object. Our object, oh, got it. This needs to be reference counted. Otherwise, we're actually we're cloning the instance instead of cloning the reference to the instance. That was dumb. All right, so if we do this, and now we have to fix all the compilation errors, there shouldn't be too many, then we will have a working setter. Oh, was that it? Was that the only compilation error? Okay. Cargo run set. Yes. Okay, so it printed out 12. All right, so that was an easy bug to fix. Always clone your references. Never clone your objects, your instances. Okay. Try to keep that in mind, and then that'll bite me later on in life. All right, so instance of bagel. We'll say, oh, let's get rid of that print. Don't need that. All right, and if I cargo run this and use my little fancy syntax here, bagel b.foo equals 12 is fine. And if I say look at it now, I do see a locks class, which is an instance. Sorry, I see a locks instance of a bagel class with fields. It has fields of foo of number 12, right? And then I have a class called bagel, which I named bagel, and then there's a clock as well. Nero Cat, thank you for the follow, much appreciated. All right, so that's 12.4. We got that done. Let's see, I have about an hour left. That should give us enough time to work on methods on classes, right? Let's check in with Clippy again and commit these changes. Git add generate in source. Git commit section 12.4.2, right? That's 12.4.2 setters. Yep, 12.4.2 set expressions. Yeah, so get expressions, set expressions, and now let's work on methods. Methods on classes. All right, you can create instances of classes and stuff data into them, but the class itself doesn't really do anything. Instances are just maps, and all instances are more or less the same. To make them feel like instances of classes, we need behavior, methods. Our helpful parser already parses method declarations, so we're good there. We also don't need to add any new parser support for method calls. We already have those, getters and function calls. A method call can simply change those together. That raises an interesting question. What happens when those two expressions are pulled apart? Wait a minute. So do we already have this kind of behavior then? Because if everything's there, so if I say class foo, and we just create a method called bar, and bar prints out I am in bar. Can I just say var f equals foo, and then say f.bar, print calling f.bar, and just say done. Will this work? Cargo run method. No, undefined property bar. So it doesn't call it yet. So that raises an interesting question. What happens when these two expressions are pulled apart? Assuming that method in this example is a method on the class of object and not on the field on the instance, what should the following piece of code do? Bar m equals object.method m argument. This program looks up the method and stores the result, whatever that is, in a variable and then calls that object later. Is this allowed? Can you treat a method like it's a function on the instance? What about the other direction? All right, let's copy paste this. Call it box locks. So this program creates an instance and then stores a function in a field on it. Then it calls that function using the same syntax as a method call. Does that work? Different languages have different answers to these questions. One could write a treatise on it. For locks, we'll say the answer to both of these is yes, it does work. We have a couple of reasons to justify that. For the second example, calling a function stored in a field, we want to support that because the first class functions are useful and storing them in fields is a perfectly normal thing to do. The first example is more obscure. What was the first example? Oh, this thing here? I guess we can also, let's write that and then we can edit method And we can just say let bar call is equal f dot bar print calling f bar through bar call, and then just say bar call, and then say done. Like that. And this won't work. This won't work. Neither one of these will work. Call the function with argument. What does that mean? Call function with argument. Oh, wait, so that actually worked. This already worked. Neat. So we were able to set a field on box, which was a not method, which is actually now a method. So now we can call that. Neat. Okay, so that already works. Cargo run. And this one doesn't, right? Yeah. Bar call. Expect semicolon after that because I have a typo. Oh, no, I don't. Line 12. Oh, let. I said let bar. Here we go. Yeah, okay. So we still have that. So this is what needs to be fixed, but this already works. The first example, which is this example here. No. This example here, yes. Var f equals bar call and call bar call. So the first example is more obscure. One motivation is that users generally expect to be able to hoist a sub-expression out into a local variable without changing the meaning of the program. You can take this and turn it into this. Right. And it does the same thing. Likewise, since the dot and the parentheses in a method call are two separate expressions, it seems you should be able to hoist the lookup part into a variable and then call it later. We need to think carefully about what the thing you get when you look up a method is and how it behaves, even in weird cases like this. So will this work? Let's find out. This. Oh, we don't have this yet. Okay. A motivating use for this is callbacks. Motivating use for this ability is callbacks. Often you want to pass a callback whose body simply invokes a method on some object. Being able to look up the method and pass it directly saves you the chore of manually declaring a function to wrap it. Compare this with this. Boom. Okay, so if we look at this, we grab a handle to a method on some instance, like this, and call it later. Does it remember the instance it was pulled from? Does this inside the method still refer to the original object? So is this Jane? If you call methods at some other later point, what happens if Jane goes out of scope and gets dropped? Here's a more pathological example to bend your brain. All right, so this pathological blocks. And we still don't have this, so we're not going to be able to run this anyway, but we'll keep it for later. Does that last line print bill because that's the instance we called the method through? Called bill.sayname. But if bill is equal, bill's.sayname is reset to Jane's.sayname, does it remember that Jane was Bill's sister? I don't know where I was going with that sentence. Does the last line print Bill because that's the instance that we called the method through, or Jane because it's the instance where we first grabbed the method? Equivalent code in Lua and JavaScript would print Bill. Those languages don't really have the notion of methods. Everything is sort of functions in fields. So it's not clear that Jane owns sayname any more than Bill does. Lux, though, has real class syntax, so we do know which callable things are methods and which are functions. So thus, like Python, C# and others, we will have methods bind this to the original instance where the method is first grabbed. Python calls these bound methods. I know, imaginative name, right? So this is all talking about, I mean, this says methods on classes, but we're really, where he's honing in on is the whole, how do you resolve the this keyword? In practice, that's usually what you want. If you take a reference to a method on some object so you can use it as a callback later, you want to remember the instance it belonged to, even if that callback happens to be stored in a field on some other object. Okay, that's a lot of semantics to load into your head. Forget about the edge cases for a bit. We'll get back to those. But now let's get basic method calls working. We're already parsing the method declarations inside the class body, so the next step is to resolve them. Oh, okay. So what we're doing here is handling this situation here, cat method, right? Where we have bar is in foo. It's just that we can't call it yet because it doesn't recognize it as a property, right? If I say cargo run, and I just put this in directly here, class foo bar print I am in bar, so we call it, and that's the whole class. I say look at the class. We have foo as a locks class, right? Foo is the key, class lock class name foo is the value, but even though we parsed it, we didn't put it in the class. So that's what we need to do next. So in the resolver, we're going to start doing that. So next step is to resolve them. So in our visit class statement, which is right here, we have declare and then define. I see the define right there. And then, so now we're going to go through each function method. Storing the function type in a local variable is pointless right now, but we'll expand this code before too long and it will make more sense. Okay, that's right. We have this function type and we're going to make a method. So, okay, let's do that. Method. I see it right down here. I'm just skipping ahead slightly so that I can actually get this code to compile. For method in statement methods. I'm going to say, oh, right. So he's saying putting it in a local variable doesn't make sense, but we'll expand it later. Like declaration is function type method, and then call self-resolve function, which is going to be method and declaration, just like that. I don't know if this is going to work. We might have to clone it or something. Let's see. Okay. So as how do we deref it? Just like that? Yeah. Expected struct function statement found struct RC. Deref? Oh, we're gonna have to pull it into a function statement. Statement function method equals method deref, and do this. Else we have a system error. Error return error box result system, I guess runtime, and it'll be statement dot name class method did not resolve into a function statement. Semicolon. Okay. 2 warnings. What are the warnings? Resolve function needs a result. Okay. Good. Oops. I didn't mean to quit that one. I meant to quit the other one. All right. Anyway, it built. Let's take a look at it again. So we loop over all the methods. We have to deref out of the RC. We're saying we're going to deal with a method function type, right? We destructure it into a function statement, and then resolve the function on that. Okay. It's going to be important when we resolve this expressions. For now, don't worry about it. The interesting stuff is in the interpreter. All right, let's go over to the interpreter. Oops. There we go. We're replacing one line. Environment define. There's locks class right here. So it's right between these two guys. We're going to do this. Let methods is equal to hash map. Yeah. For method in. What do I have to do? I have to do statement methods deref. Right? I'm going to grab the function. Oh, we're creating a new locks function. Oh, how are we going to do this? All right. How are we going to do this? So we're going to, let's see, function equals, and a locks function is, this has to be map string to locks function, but this has to be the object type, right? I think we have to say object function, right? And then what is that? Oh, func, which is a callable. Ooh, I might have to create a brand new method or something. All right, callable. And then callable takes a new, maybe? Has a new? No, it just says pub func log callable. So I can just say func rc new of, and then hopefully locks function implements locks callable. It does. Okay, so we can say locks function, and this has a new. Yep. New. Wow. And then we take the method, which is the function statement. Oh, right. So we have to, just like in the resolver, we need to destructure it. Like that, or panic. Actually, what we do is, let's try this. I'm messing around here. You can say let function equals this, and then just panic if we don't have a destructure. So locks function new takes the function statement, right, and then a closure, which is the environment. Oh, I guess that's just our environment, right? Self environment. It's RC ref cell. So I'm going to take a quick peek up here. I'm going to have to borrow it. Ooh, can we even do that? Let's try it. It might complain about the fact that we're else panic. Non-function method in class. I'll just do that, and then we can expand that later if that ever happens, but it shouldn't, because the resolver should have caught it already. And then class Oh, we're going to pass in the methods to the class. Okay, let's see first if this works. And then after this, we say methods, insert, method.name.asString. Right, that's the string side, and then the locks function is, which is the object side function. Okay, let's see what blows up here. Needs a semicolon. Yeah. Mismatch types. Expected reference found struct ref. If I do that, see, I'm worried that it's just going to say, oh, maybe I can just clone my way out of that one too, because that's a, oh, right. This needs to go here, and this is method. This is func as string, right? Func name as string. So we can just do this. Yeah, look at that. I was thinking we'd have to do an RC clone on this, but it looks like that just worked. All right, and then we're going to need to pass in the methods into the locks class. So if we look down here, I mean, I can just put that like here, methods, right? And then we just assign it there. So in locks class, we're going to add methods to here. It's just a hash map from string to locks function. Hash map string, which actually is an object. Oh, I wonder if I should just be putting the locks function directly in instead of dealing with the object. I wonder if that's going to cause us headaches somewhere along the line. Maybe not. Maybe not. Let's try it. Let's give it a shot. Locks function, which means we have to go back to this guy here, and instead of doing all this nonsense, we just say create a locks function, right? Oops. This is what. Ah, jeez. There. Right. Oh, we don't have hash map. Use standard collections. Hash map. Locks function, which means we don't have locks function. Self is missing methods. Okay. And then it doesn't like this because expected one argument but got two. So that just means we need to change our new to take in the methods. Okay. So methods is equal to a hash map of string to locks function. And that doesn't implement debug. Oh, locks function doesn't implement debug. Oh, and we can't clone. Really? And partial equal. I should not have to clone any of these, right? Because I have so many RCs everywhere. Oh shoot. Okay. I can't make statement all of this because that would mean changing everything. All right, so let's undo that. And if I get rid of that, that's going to blow up what? Locks instance now can't be debugged. I guess we can just implement our own. Shoot. Shoot. How to clean this up? Maybe we just have to punt in and put object in here. I thought it would be easier just to have the locks function directly, and then so yeah, then we have to put all this back. There, 3 warnings now. Not using locks function inside locks class. Methods is not used. Oh, it is now. Okay. So that's good. We're not actually reading methods anywhere. I'm surprised that Most doesn't complain about that, but maybe that's too nestedly deeply complicated for that. All right, so this checks out. We actually now have methods on classes. The question is, can we call them yet? And I don't think so. So when we interpret a class declaration statement, we turn the syntactic representation of a class, its AST node, into its runtime representation. Now we need to do that for the methods contained in the class as well. Each method declaration blossoms into a locks function object. That's inside here. We take all of those and wrap them up into a key map, keyed by the method names. That gets stored in locks class, which we've done here. Where an instance stores state, the class stores behavior. Locks instance has its maps of fields, and locks class gets a map of methods. Even though methods are owned by the class, they are still accessed through instances of that class. So in locks instance get, we need to have a find method function, or we need to call class's find method function, which doesn't exist yet. So instance. So else if let some method equals self class find method name as string, then we're going to say okay, and it's an object, so that's good. Method else we throw the runtime error. Okay, so when looking up a property on an instance, if we don't find the matching field, we look for a method with that name on the instance's class. If found, we return that. This is where the distinction between field and property becomes meaningful. When accessing a property, you might get a field, a bit of state stored on the instance, or you could hit a method defined on the instance's class. Looking for a field first implies that fields shadow methods, a subtle but important semantic point. The method is looked up using this. So we got to write our find method. Yep, it doesn't exist. Oop, I forgot this thing, and find method doesn't exist. That's the only error. So let's pop back over to class and write a find method. So how do we do this? And we just take in a name, which is string. Return we're going to return a result, right? No, an option object, right? Because I said sum. So if method contains key name, return method get name, otherwise return null. All right, that's easy enough. All we have to do is say self.methods.get name. Oh, I pass in a stir. Do I have to say toString? And stop doing that. Expected option object. What did you get? Isn't that what you got? Oh, found a reference. Oh, really? I have to clone the method out of there? That's annoying. No, that's not it either. So if I change this to string like this, does that help with that second problem? Okay, that I can change, right? Like doing this. Yeah, okay, so the only thing left now here is this. So it's not clone, it's what, as dref or as ref or something like that? No. Huh. There's something that allows you to convert this second one to the first one. I thought it was as dref, but must. Try to scan this really quick. Yeah. This is expecting a ref. I want to do the other way around. Nope. Noob needs help. That sounds like me. No, that's useless. I don't like that. Ways of going from option string to option string, right? That was back in 2017. My connection is not private. That's a shame. Let's see the cached version of that page then. Okay, instead of dref requires dref mute, can mute option to mute option that. Oh. I mean, that means I have to clone it out of there, right? Which is, no, I just wanted to return that. I mean, I could always do this and then have to fix it in the next, up here, right? Right, I can just say method clone. Right? That's kind of an annoying way to fix it, though. But I guess that's a reasonable option. Dang it. What if I do this? I don't have to clone anything. Although this guy now gets annoyed, because in our visit get expression we have to return an object. So this now has to get cloned. Oh, O is barred. So we can't do that. All right. So never mind. Nope. Oh, because I still have the ampersand. Ah. Okay. Should we see if this works? So this should work now, right? This little bacon example here. Crunch, crunch, crunch. Okay, so that was section 12.6. Now, I can't use these guys because they have this in them. Okay, but this works. This example works also. Calling f.bar returns IAM in bar. Calling f.bar through a bar call returns IAM in bar. If I take a look at this, so we have a class with a bar. This is IAM in bar. I create an instance of the class f. I call f.bar, which calls bar directly. Here I assign bar call to be equal to have the value of the method, right? And then I can just call that using this expression. So even though this is not a function itself, it's referencing this method inside the class, and that worked right here. And actually, I can just, let me just make it a little more explicit, because we can take an argument. Bar from arg, right? I can do that, and you just say f.bar here, and I can say bar call here. Bar from f.bar, bar from bar call. Perfect. So, okay, so that's working well. Japfa says option cloned is what you're looking for, I think, not option clone. Oh, in which method? When I was going here, right? I was calling the class find method. So do you think I was trying to go get cloned here? That would have been a better. I'm not familiar with that one. Oh yeah, that works. That works fine. Thank you. Yeah. All right. So I guess either way works, right? So either we can just return the reference to the object and then clone it in the instance, or we could do this where we return a clone of the object and then just keep returning that back. And this all this does is return a clone. It would be nice if instead of cloning the object, this was actually just RCs that we were cloning. I don't know if I want to take that extra step right now, though, because I have everything working. All right, thank you, Japfo. All right, so git status, git. And this was section 12.5, methods on classes. Yeah, 12.5, git. Let's check in with Clippy before I do anything. TTG says, why do you use ampersand string instead of ampersand stir? Well, let's try it. Oh, maybe, okay, there you go. Is this the one you're referring to? I think I was having an issue and I was trying to get it to compile earlier, but I probably broke it. 33. We can just say stir. Oh, it was calling this into here. Maybe it was giving me a headache. Yeah, that works. So is that the one you were referring to specifically, TTG there? All right, so that's clean. Git add source, git commit, HM section 12.4, methods on classes. All right. TTG says good. Excellent. All right. I have maybe 15 minutes left. Is that enough time to get through this? Or should we save this for, looks like we should save this for tomorrow. Okay, well, let's save this for tomorrow. I will dive right into this first thing in the morning. We'll get this done. And then how close are we to the end? Actually, I'm curious. Where's the table of contents? Here. Here. There we go. Okay, so we're near the end. All we have left is after we do this, we do inheritance, and then we're done. Okay. So 12.5. Find it? Can't find it? This? Yeah, can I use methods on? Wow. So this whatever formatting they're using is making it awkward to. Oh, and then constructors and initializer. We have 12.7. Is that one? What's 12.6? Oh, is that? Yeah, 12.6 is this. Okay, so we have this, and then we have constructors and initializers. All right, and we will dig into both of those tomorrow. Hopefully we'll have time for both of those. Meanwhile, is there anybody to raid? I don't see anybody else doing Rust right now, unfortunately, which is a shame. Okay. we'll leave it there. Thank you everyone for hanging out with me today, and hopefully you enjoyed it as much as I did. Tomorrow we'll do this, and we'll do constructors and initializers, and we're going to almost wrap up the first half of crafting interpreters. So close. We're so close. Hopefully, maybe we'll be able to finish out part 1 by the end of the week. All right. Well, take care, everyone, and have a great rest of your day.